In this first video, we'll go through how to do the base problems, and then in the next one, we'll talk about word problems. Starting with number 1, rewrite the problem. 5x squared over 7 divided by 10x cubed over 21. And really at this point, if you're not sure how to divide fractions, then you need to be seeking extra coaching from that. So I'm only going to say that when you divide a fraction, you got to multiply it by the reciprocal. That's how it's done. So the flipped version of the fraction is reciprocal, so I just rewrite it in the first step, showing it upside down. And usually this means that these numbers will nicely cancel out. And from an earlier section, you would know that if I have x squared down here and x cubed, then 3 minus 2 gives me 1, and I would be left with just 1 down underneath. 5 over 10 cancels out, leaving me with a 2 down underneath. And I scan through to make sure that nothing got left behind. I have 3 in the numerator, and then 2x in the denominator. That is problem 1. I'm going to clear this out and see if I can orbit this or move this around to where I'm looking just at number 2. Number 2 says that n plus 1 over n plus 3 is going to be divided by 2n plus 2 over n plus 4. Now, you could do this in all sorts of different order, but, to encourage not making mistakes and combining things in one step, I'm going to wait to factor 2n plus 2. So I'm only going to rewrite that. Now, I look through this and I'm like, well, I could save myself some effort if something canceled out, but that doesn't. So then in the numerator, I'm going to rewrite n plus 1. I'm going to write this in parentheses, and I'm going to write it in the same fraction, because that's what's going on. There's no breaking apart of the n plus 3 or anything up top. But then down here, I'm going to write 2 times n plus 1. Now that I have this, n plus 1 cancels out, and the only thing that remains in the numerator is n plus 4 over 2 times the quantity n plus 3. Now, you might have a couple questions now. If this feels comfortable, that's great. But your questions might be, well, why is it okay to just, put parentheses around that like I did? Why is it okay to write 2 like that? Well, really, the entire numerator of the original fraction is going to end up being multiplied by the entire denominator of the other one. And so as long as I keep things in parentheses, I'm making sure nothing gets messed up. Problem 3. Rewrite 15y squared over 4x divided by, and as you do these, I do want the original problems rewritten. Do not jump into that first step where you've already flipped the fraction. Do not do that. Then I have 15y squared over 4x times 8x cubed over 5y. I really do avoid trying to cancel anything out before I've flipped the fraction. It only encourages mistakes. 15 over 5 becomes 3. 8 over 4 becomes 2. I scan through. I see y squared. I see y. And 2 minus 1 means that I'll be left with y, and that's going to go away. 3 minus 1 means I'm going to be left with an exponent of 2 attached to x. So in my opinion, the only issues that you run into here is, leaving things out. Here's 3 and 2 becoming 6, so maybe you would accidentally only write the 3 instead of 6. I do have x squared in the numerator, as well as y in the numerator. And that little pause that maybe you noticed me doing, that was me losing my train of thought and thinking that y was going to be in the denominator, because in the previous problems we had like a variable up top and a variable down below. So I was anticipating that that was going to happen again. So to me, like, I hiccuped for a moment and I had to look at it. Well, the problem they give you is the problem they give you, right? I mean, it's not like it's going to always stick to some rule. So there I had to scan through to make sure I didn't mess up. I'm going to check out the other problems and let's see if I think they merit being done. 4, pause this video, make it an on-your-own problem. Once you finish it, move on to number 5, which I will go through. Okay, so I'm going to start number 5, so make sure you pause and finish 4 and check your work. I'm not going to even put the answer up. b plus 4 over 3b plus 2 divided by 3b plus 12 over b plus 1. All right. Now, if I could factor the numerator here, I would, because there's no flipping involved. If I could factor the denominator here, I would, but I can't, so I'm just rewriting all that. Now, I wouldn't factor anything over here, because that might jumble my steps. I want to be able to see this entire problem, so I'm panning that up. I've only flipped it so far. b plus 4 gets rewritten over 3b plus 2 times b plus 1 over 3 times b plus 4. If you'd like to see this, you can put a parentheses around here. And this time I kept it separated. I mean, sometimes I do, sometimes I don't. If you want, you can put parentheses around the numerators of these fractions. And then I see that b plus 4 and b plus 4 cancel out, leaving me with b plus 1 over 3 times the quantity 3b plus 2. And this is a finished, factored, and simplified problem. And the same old restrictions on the domain. If these were functions that I was graphing, those same excluded values would still apply. I'm looking at 6. It's a little bit more involved as far as the steps go, but nothing crazy. Make 6 an on-your-own problem, and I think you should be fine. I'll put the answer up only. So wait a few seconds and you'll see the solution. Hopefully you didn't stumble too long over this one. This is kind of a sadistic problem. I think maybe it was retyped incorrectly, or maybe the textbook was incorrect. Because in this problem, nothing really cancels out. So if you stuttered there for a little bit and got stuck on this one, I apologize. But your life will go on. I can change this to 11, though. All right, find each quotient. Now look at these. It's the same directions, right? So there's really nothing different as far as the instructions go here. Again, we're dividing. And I'm going to zoom in so that I got plenty of room to work with. And instead of seeing binomials that I'm factoring, I'm now seeing trinomials. So I'm going to rewrite m squared plus 3m plus 2 all over 4 divided by m plus 2 over m plus 1. Now I'm looking for the factors of 2 that add up to 3. So I'm going to rewrite the left fraction's numerator as m plus 2 times m plus 1 over 4. But now I'm going to rewrite the other fraction flipped because I'm dividing. And I've already talked about that. I'm throwing some parentheses around this to help me see that m plus 2 cancels out. But don't get too egregious, it's a good word, by canceling out m plus 1, because both of those are in the numerator. So I'm going to rewrite m plus 1. I'm going to square that, and I'm going to do that over 4. And this is your factored finished solution for problem 1. Problem 2. P squared minus 4 over 5p divided by p minus 2 over p plus q. As I look at this problem, I recognize that this is a perfect square deal. And when I factor p squared minus 4, I get p plus 2 times p minus 2 over 5p. I'm totally confident factoring this on the left because you never flip the left fraction, times p plus q over p minus 2. P minus 2 cancels out with p minus 2. And in the numerator, I will have p plus 2 times p plus q over 5p. And that's finished. I scan through, I make sure no values could be pulled out. Like if I had a 2 there, I could pull 2 out because it wouldn't totally be factored. And as I look through this, it's all complete. Yep, this one can be an OYO. This one's totally fine. I'll put the answer up only for this one in 5 seconds. Q plus 2 times the quantity q squared plus 4 over 12. Now, if you look at q squared plus 4 and you tried to factor this as something plus 2, something minus 2, it's just not the same thing. You can't factor this without imaginary numbers in solving. All right, clearing this out. Bam! These are all the types of problems that you'll do before we move into real-world problems in the next chunk. All right, hopefully you feel comfortable with this. Hit me up with what questions you have.